So this is why we are going to have a good or a foundation on geometry, and we're going to make sure that, I mean, if you already have decent idea, that's going to be a good opportunity to polish yourself. All right, so we have trigonometry, angle, okay, Pythagorean theorem, trigonometric function, polar coordinates, application of basic and then exercises. All right, trigonometric, okay. So applicable real world problems, we have surveys, navigations, we have physics involved in it. And you know, when we talk about physics, physics is nothing but a numeric representation of natural science. Okay.
Yeah.
And you all know that everything has numbers to it. We have numbers to say it's 40 degrees. Why we say 40 is hot? Why we can't say 40 is, I mean, what made us decide that 1 degree is gonna be that much of a heat? We just made it out of our calculation. There's a long story behind this. Physicists said, okay, this is how we see energy. There's energy. A number, human mind understands the number, and that number maps to the feeling. So if it's 40, without any second thought, we can imagine it's not an ideal situation to go out and have a good picnic. If it's 50, no way. If it's 30, it's just a number that comes in. And we do understand that these numbers are the most powerful things, or there is one of the most powerful tool in computer. Okay, so that's why it also involves physics. Game developers, geometry of 3D geometry and physics. Everybody knows that. If no, you might have seen the making of lots of videos in which you can see the objects are made up of triangles, right? Lots of triangles. Some of the triangles are curvy. We call them Beziers. They have dots to them. It's just like the model is not that. So there's no such thing as solid surface model. We have model it into triangles. We model it into angles, rotation. We model it into dots. We model things into curves, and then on the base on the top of that we put the textures. Okay, so that's where the game developers do need to know what the geometry is about. A very small example. Can you tell me about this? um, when you have like when you if you, when you're wearing a shirt and there's a drop of water on your shirt, that spot becomes dark, right, comparatively to the rest of the shirt if it's a light shirt.
Mm-hmm.
Okay, and you can easily distinguish the spot. What's happening? Water absorbs light, and the only thing we see in our real life is what is struck the object, and in the reflection struck our eyes. If it struck our eyes, we can see it. If it does not struck our eyes, the reflection of the light, we cannot see it, no matter how bright that thing is. We have this kind of capability to see top or bottom or side or top, front, side. We cannot see the top and the bottom of the thing at the same time. We cannot see the front and the back of the thing at the same time. We cannot see two sides of the thing at the same time. Why is that? Because of the light. The light hits the object, it goes back. If it goes back to your eyes, you see it. But it goes to the other way, you can't see it. Simple formula, simple equation. Okay?
I
And
have a question,
yeah.
and it's topic related question.
Mm-hmm.
Um, so in further lectures and classes, will it
Mm-hmm.
be only geometry or we should expect physics as well? Because now you were just talking physics about light and movement.
I'm talking about the geometry behind physics, which means I'm talking about vectors, I'm talking about the angles, I'm talking.
Yeah, but further in
But I
further
have to give
classes.
you, yeah, I understand that. I have to give you an example that why and where it's needed. Okay?
Mm-hmm. Okay,
So when
thank
we
you.
do when we do vectors, you can easily connect that. A very good question, but yeah, that's why. Cool. All right. So let's move to first thing, and the very first thing is triangle. How many sides triangle have? Three, right?
Mhm.
Yep.
Please don't say four. I can't do anything from here, but okay. All right. So it has three sides. Okay.
Mhm.
Angle. The sum of the inner angle is 180 degrees. Agreed?
Yep.
Mhm.
Okay. And it's just a description to that. There's a right angle triangle, which means one of the angle is 90 degrees. Any angle less than 90 degrees called acute angle. If you can forget the word obtuse and acute, just remember acute with the C. C means less than 90 degrees. Okay. So
Okay.
anything less than 90 degrees is acute angle. Anything greater than that is an obtuse angle. All right. So this is what we have. We have obtuse triangle. We have acute triangle. And we have right angle triangle. So if you can see that, this is right angle triangle, this is obtuse triangle, and this is acute. Okay. So if you look at the C part, acute. O part, no. Right and obtuse. Okay, cool. So there's other type of triangles. You have equilateral triangles with me. All angles are equal. Isosceles triangle, exactly two angles are equal. And scalene triangle, no angles are equal. All right. Yeah. Reflex angles. Yeah, reflex angles are less than always acute. They can never be obtuse. If they're obtuse, then you can't see it. For example, the reflection. You have to make sure that if it's coming or it's outward. We do that in the rotation and geometry anyways. Cool. That's the answer to Kishan's question, which was, I don't think so, it was a serious one based on the emoji. All right. Okay, cool. So you just trying to tell you how it becomes one. All right, cool.
Mhm.
All right, sweet. Now, coming back to this, but remember when we scale something, now there are three things. Do remember that. And coming back to Lyra's question as well, I will and try to give you examples and relevance to the applicable areas. Okay. So same thing here. If you are doing scaling, in scaling, what happens is when you do the scaling, nothing else is changed, just the size is changed. For example, a triangle, the sides size will be changed, but the angles would remain the same. So, for example, there are two ways of looking at an object. If you look at an object and if we want to decrease or increase the size of an object, we are doing the scaling. But if we have an object with a fixed length and we are going to the distance, if you're far away, it will become small. That scaling is basically going through translation. You're far away from the object, but the object itself has an original size to it. Okay. So
Mhm.
you can't say that that is being reduced. But if something is reduced, we can scale it on all the directions, or you can scale it in one direction, x-axis and y-axis or z-axis is all up to you. And if we say we are going to translate something, we also have to make sure where we're going to translate. Transformation is basically what I'm trying to say in this whole situation. In geometry, relevant to the designing or to OpenGL, there are three things: translation, scaling, and rotation, which are prominent. Rotation I just told you about. Scaling I just told you about. It's just like an example, and translation is the distance. Okay.
Okay.
So, how many of you know this thing now? Hypotenuse, opposite, and adjacent.
I know.
Cool. All right. So this is 90 degrees. Opposite is an angle. So opposite.
35. Oh, wait, no,
Okay.
45.
Yes. Perfect. All right. So this is a Pythagorean theorem, which is say the length of this is c square is equal to a square plus b square. Okay. In other words, hypotenuse square is equal to opposite plus adjacent. All right. So this is how we define it: adjacent, opposite, hypotenuse, because A, B, C are quite common. So in real world, we just use it like that. Now, sine, cosine, and tangent. These are the angles, how we can find an angle. So if we are given A, O, and H. So for example, if we know just O and H, we can find this angle, which is sine theta, opposite divided by hypotenuse. And then how can you do it? In the calculator, you can see you have sine and sine inverse on your scientific calculator. So all you do, you do and then do the inverse sine, you get an angle. And if you get an angle, you know this is 90 degrees. 90 plus this minus 180 will give you this angle. Done. All right. And if you really want to know what is the value of this one, uh, sorry, yeah, you can do it with this. Sweet, cool. Now sine graph. Okay, so if you see the sine graph is like that, and cosine graph is basically the peak is at 0. It goes like that. Now, these are typical information that you will always be needing some way or the other. So just remember that when you have 90 or cos 1, it becomes 0 as a value of those angles. So it's trying to say what is the maximum value of sine and cosine is this. So on 0 angle, it's 0. On 90 angle, the maximum is 1. Then it becomes 0 and 180 degrees. Then at 180, and then after 180 you add 270, it will be minus 1. Goes like that. With tangent, it goes up. So tangent 90 is not applicable, goes tends towards 90 but never reach there. So you always have these angles. All right. So these are all angles on x coordinate, and these are the values. All right, sine x. So sometimes when we have to increase the we want to increase the peak of the sine graph, and what we can do is we can just multiply a number outside sine, and it can increase the peak of the graph. Now where we need it, a very small example, when you do OpenGL programming, you want to have a ripple of water, and you really want to make sure that when you have ripple of water, it's not of the same size. For example, you throw a stone, there will be a ripple around it, but there will be a peak near the stone, and then it slows down around it. That goes gradually based on the how big the stone is and what is the speed and everything like that. And that works through OpenGL. And for that, if we know the concept that how the peak is working, we know that okay, to play with the peak is now. So you can see this is a regular one. If you put an extra 2 to it, the blue one, it will increase. If you do the fraction to it, it will decrease. So you can control the peak. Next is if you want to shift. So if you want to shift, you just say, okay, this is a formula. You just add to the angle, it will shift. So for example, if this is the one with an amplitude, and if you want to shift, if this is the red one was the original one, you want to shift by 90 degrees, so it will shift 90 degrees. If you want to shift minus 90 degrees, sorry, it will go the other way around. So if you want to shift, you have to add to the angle. If you want to have an amplitude, you can do that. Okay. What if you want to increase or decrease the frequency? You multiply with an angle. You will increase and decrease the frequency. So at this very moment, I'm not asking you to draw or program a water ripple. Just remember, if it's all about the peak, you multiply the whole sine formula with the number. If it's about shifting, you add to the angle. And if you want to change the frequency, you multiply with. This question is all right or still too noisy?
That you seem good.
Mm-hmm.
Yeah.
Okay. a quick recap. Triangles, Pythagorean theorem, good. What is the formula of sine, cosine, tangent? I'm not asking you to write fingertips, just letting you know that, okay, you know where to find and how to calculate that. When it comes to the sine, amplitude, frequency, and shift, you know what to do. You multiply the number with sine, you get an add to the angle shift, and you multiply to the angle and give you the frequency. Now the new thing is the Cartesian coordinates. Cartesian coordinates are just x and y values. All right, so if you see this is the center, y, x, x, y. -3 is on the first part is x, second part is y. So -3, 1 means you go to the negative, you put a dot, and you can have -3, 1. And based on that, polar coordinates instead of x, y, which is basically an angle and the length of a line, which would basically give you x, y. So when you need to know at what angle, how far the object r theta works, but you exactly want to know the location, then Cartesian coordinate works. So there must be a question that how they are going to link it with each other. It's easy. This is how you calculate. Yeah. So this is how you calculate r and theta with r and theta and xy. So this is r, this is theta, distance, xy, and r is this. Let's move on to this. So the polar coordinate describes the point at R, which I just described you, from the origin. Remember, it's from the origin. And this is how it looks like. These are the numbers, and these are the angles at 150 degrees, which is in form of a radian. Now there are two different ways of doing it. Radian, and another one is degree. When we are talking about radian, we have to add a pi to it. And if you're talking about degree, it's just a number. Okay, the coordinate quotient, they are just different way of calculating it. So if you have a degree which is 90 degrees, you multiply by pi, divide by 180, you get something in radian. And if you're given a radian, you just multiply by 180 and then divide by pi, which is 3.14, you get a degree. All right, if you want to keep it in the form of pi, you can keep it in the form of pi. If you do not, you do not. If the questions asked ever to you in your exercises or tasks, all right, just it will be either precisely mentioned, explicitly mentioned, or if it's talking about 1 or 0.1 or 1.2 or 3.1, you're definitely talking about radians. All right, so pi is basically 3.14. If you can add more values to it, it's fine, but it's all good. Otherwise, you do 22 by 7. And basically, in other words, pi is equal to 180 degrees, which is 2 pi is basically 180 degrees. Pi is 90. It's just a quick way of seeing what's going to be the answer. All right, cool. So, for example, if I have, how many radians would we have to rotate the ray to do this? So if you have a circle, we have a radius, and this 2 pi r is a circumference and r is a radius. Circumference means a total length of the circle. If you straighten the wire, it will give you the length. So it's 2 pi r. So if r is 1, it's just 2 pi, which makes sense. Pi is 180, and then 2 pi is another 180. It makes a circle. Okay. And if the radian is 1, it will give you the radian form. Common angles, there are a lot of angles on that part. So we have xy coordinate. So this is, do you remember that? R sine theta, coming back to this, the relationship between r and y. So if you ever want to have x and y given the polar coordinates with it r and an angle, you just do the angle sine, multiply by r, you get a y. You do the angle cos on calculator, multiply by r, you get an x. So these are the Cartesian coordinates, and r and theta are polar coordinates. So now you know the conversion as well. So next, If you look at this, for example, we have a point here, we have a point here, we need to find values. We can represent it like that. H squared is nothing but x1 minus x2 squared plus y1 minus y2 squared. So if we have these two, we can still find the hypotenuse. So if I know this, I know this, I can find it. Okay, that's another way of finding it. So x1 minus x2, y1 minus y2. Remember, if you have this and you have that, so you can do either way, but since there's a square, it doesn't matter. You can do negative this one or negative that one, doesn't matter. There's a square at the end. It matters when you do vectors. Okay. Why? Because if you want to find the vectors between the 2 points, the direction in the line, direction does not matter. So definitely this is not a more effective way of doing the circles. If you look at that, guys, what we would do if you want to polish up your programming skills. By this time, you know how to do the slot machine, and you do know that how to put a X symbol on the screen by using go to XY. You can use this as your function, call this function, and it will draw a circle for you. Remember, in the whole picture, everything is going to be defined by you. This is just display point, just like you want to print something on. So when you do the display point, this for loop will keep changing the display point, and when the whole for loop is finished, you'll see there will be circles all around. Okay, so do try this. Okay, you have another function display point, which you do for the printing, and here you give the radius and all the values. Just give any radius to it. Angle counts, how many counts you want, like in 180 and 360 degrees, how much you want in the whole scenario. So for example, if you want to have angles after 10 10 10 or 8 8, whatever you want to, and this is the center. So if you definitely need a center, because on the screen you have to decide where you want to draw it. So give it a try. Okay, so the only difference between ellipsis and the circle is this part. Okay, that's nice. Perfect. And so you can use the snippet and just use it for your C++ part. See, this is a good example. You already did something over there in your Spice Invader one, and I suppose it's on your Game Maker. Now you're gonna do it in C++. Now you actually know that it's applicable, and you know what's going on from the programming perspective. So you see that how they are kind of, not kind of, but definitely linked to each other when it's needed. Thanks, Neris. So where else? Yeah. So if you can draw the circle, you can draw the ellipsis. And how to draw the ellipsis? Simple. The only difference is that there are two radius, horizontal radius and vertical radius. So if you look at this one, there was only one radius being used for both, but in this there will be horizontal radius for X and vertical radius for Y. That's all you have to do. Okay, and you have to find the radius of, just start with anything. With it. Just a little change and a circle becomes an ellipse. So what you learn from this quick thing, that in the circle you have one radius, in ellipsis you have two radius. All right. So so we have modeling waves too. So this is just an example how we model waves. When you do OpenGL, and I'm quite sure that once you're going to go into OpenGL in your second year, you're gonna love it, the way you're going to do effects, the mirror reflection. Actually, you can control the game as well. I mean, it's hardcore programming, and it's gonna be awesome in a sense that you're going to use some functions, the built-in libraries, and you're doing it smartly. You're not actually making an overall mad reflection, but using it. Okay. Now the question comes in and said, hey, why they keep updating the OpenGL libraries is there an end to it when it comes to the effects? Well, those people who update the libraries are the ones who were once the programmers, like who were digging into how the mass link to the programming and where it's needed. So they always try to refine and optimize the solution to get you better libraries. Okay, so it's just information. You don't have to really program that part. You will program sine waves, but I'm not letting you go with. But you just need to remember that if you have a sine formula with this being a frequency, this becoming a shift, and this becoming a amplitude, you can use that to make a wave. And this is for a gradual wave where you can have a power where it goes down and up. It's just an explanation of that. And this is how the effect comes in 3D. So we're not going to do all this. All information you need to know is just the sine one. In your exercises, you're asked to do a sine wave in an animated form from left to right or right to left. Just practice that. Okay. All right. So that's from my end for this one. Do you have any questions? Anyone? Guys, wake up. I finished.
Not specific to this lesson.
Okay,
but
yeah. Anything for this thing? I mean, first of all, on this one. Anyone else? Cool.
Yeah, I don't have any questions.
All right, perfect. So what are
I
you going to
have, but
do?
they are not topic related, so I'll shut up.
No. All right. Anything topic related would be great at the moment, and then we can go to the next. All right. Cool. That isn't confused on. Okay. Do not have to worry about this thing. The only thing that is knowledgeable for you to remember that creates waves, and this is just a function that I have already given you. So use that. Try to draw a function. You actually have done the slot machine. You actually know how to put crosses on the screen. You apply this function, it will do it for you. All right. So all you have to do, try to gather the information, see what function or what information does what, and then we move to the next phase here. Cool. Sweet. I think I'll stop here, and there will be some exercises. So what I recommend you to do the exercises as much as you can from this. And I did share the another lecture with you, which is, I suppose, should be on the blackboard. And yep, it is. Cool. So I recommend that you go through this. Okay, just go through that before we start with this most important for yourself with. Just understand what is sine, cosine, tangent, and they have their cousins. All right, sine have cosec, cosecant, sec have. All right, and then you have cosine, you have secant, and then you have tangent, cotangent. And if you want to go with more of additional information, so remember, math is fun has the details too as well, which will give you a good guidance about all these topics. So what I want you to do as your additional study, just look at quadrants. Very important, please, guys. Quadrants and all of these. Okay, these and quadrants. So and then hey, whoa. So what what we're going to do in the next session? Are we going to? I'll just ask you random questions, and then you can. I have an idea that how much you have followed this. Sweet. Okay, now anything non-topic relevant questions, please.
I was just going to ask when we can sort of expect our math test results.
Yes. Oh my God, I've already marked them, and this is what's supposed to do after the lecture. So I have with me, and what I'm going to do, I'm going to break our group into two. So I will discuss one by one on a private message. Will that be okay? Discuss your question. This is what you got score, and this is where you, if there were mistakes.
Um,
Okay, overall, it was nice. It was a very good attempt. It was really good. Most of you guys really nailed it on the logic part and sets. And definitely you built up your score from the. So they are all marked. So I'm going to have a discussion with you one by one. How? I'll just tell you. Any other question?
so quickly before you go, when will I be able to do that maths test?
Yes, yeah. So after it's math, right?
Yeah.
So yeah. So med alt, I've already noted that down on my points. So I'll call you today. Definitely, you're one of the high priority, and I'll let you know that how we're going. Okay.
Okay.
Sweet. And I'll give it now. Yeah. Anything else?
You sound like you're getting beaten up.
No, it's just.
What's the first rule of Fight Club, Callum?
What are you talking about?
I was just saying, what's the first rule of Fight Club? You don't. Never mind.
There is no fight club. Shut up.
Okay, I got it. All right. So
I'm trying to be funny.
yeah.
It was-
You
Yes,
are
you are
funny.
funny.
Just shut up and be funny.
Oh, jeez. Yeah. Yeah. You have to practice. Practice. Just watch a few stand-up comedies. That might work.
Okay, I will. Thank you.
Actually, I
Alright,
did have a
then
quick
I'll-
question.
Yes.
Just a quick overview of what's gonna be in the test. Just
Oh,
I'm seeing
awesome.
from
Okay, it's going to be proofs, counting, permutation, combination, and probability. If you have done the exercises from all of these, you're quite prepared with that. Okay, it's going to be proofs, counting, permutation, and
Combinations?
wasn't it?